briefing will be in two parts. The first is the first part I will present, and then he will continue. So I wanted to say hello and good day to all of you, and welcome to this summer edition of Weather Briefing. Hope you're all doing well. Weather today in Croatia is, I would say, very calm. Here in Zagreb, it is sunny with 26 degrees, and it was, so to say, a little bit humid, but still quite pleasant. So this picture is not from today. It's from last weekend. It was my last day of my summer vacation. So this is a nostalgic preview of my vacation that is over. But also this last weekend in Croatia was quite so to say busy. Weather situation was quite difficult, and Marko will tell you something about this big amounts of rain that fell in some parts of Croatia later. So according to our already established custom, I will ask you to indicate where you're from, and I must allow you all to all attendees. I hope that now you can start annotating, if this will work. So I still can, okay, so it works. Thank you very much for this. So we all have only few participants till now, but as I can see, we cover this, so to say, middle and northwestern part of Europe. Okay, so I think that this is all till now, and I will continue with this slide. So I chose this slide because I wanted to show you the weather reports that were reported to European Severe Weather Database in July. Why I wanted to show you this, because we all know that this summer brought to most of meteorologists and forecasters very challenging weather, and so more than 2,600 reports across Europe were received to European Severe Weather Database, and of course the most devastating events were the one with the tornado in southeastern part of Czech Republic. And if you are interested, there is a very good case study with different satellite channel products and with different satellite channels and products by Nataša Strelec-Mahović and Ivan Smiljanić, available on EUMeTrain webpage. The other devastating event was one with the floods in Netherlands, Belgium, Germany, and Austria, and also later in Croatia. I wanted also to use this opportunity to express our condolences for the victims, and also to express our shock of the extent of the damage caused by this event. So, as I already said, in the second part of the weather briefing, Marko will show you some slides about these events. So in summertime, we are mostly occupied with thunderstorms, but also fires, heat waves. One heat wave is now present in parts of the UK, but also in Southern Europe. High temperatures are already measured in early morning hours. And I wanted also to mention that lately we had several intense episodes of Saharan dust penetration into parts of into Europe, and here is one example of such dust outbreak from 13th of July. As you can see, it was very well forecast by CAMS that is available on the Copernicus webpage. And on these two satellite images, you can see how it looks like on high resolution visible image and natural colors RGB. Even this one is more clearly visible because of the lower, it is early morning, and due to low angle of incidence of sun rays, these dust particles are really nicely seen on this satellite image. But of course, as you're already familiar, there are several RGBs for these purposes, and one of these RGBs is dust RGB, and all these composite and RGB color interpretation guide you can find on EUMeTrain and EUMeTrack webpage. So in the last also few weeks, we saw lots of active fires in Europe, and this is also one product that is available on the Copernicus web page. And these products allow you to follow fire danger forecast and rapid damage assessment. I wanted to mention you these products and fire weather danger because already this summer and also today there are several countries across Europe issued warning on fire danger. Some in this Scandinavian region and northern part of the Europe, but also the fire danger is present in lots parts of Mediterranean. Okay, let's now start with today's weather. And we will begin by looking at the air mass RGB, with which, first of all, we can distinguish air masses, and its purpose is to analyze dynamic processes in the atmosphere and areas with PV anomalies. So I would again ask you if you can annotate warmest and coldest places, air masses, and their position, or maybe PV anomalies, and or position of jet streams. What do you want to annotate? Maybe firstly, where do you think that the warmest air is placed, and where the coldest air is placed? I hope that you all can annotate it. Okay, so we already have some warm, yes, great. Oh, thank you. This is very nice. So this is why air mass RGB is really gives us an opportunity for a quick overlook of synoptic situation over the whole Europe. So thank you very much for this. I will now stop annotating so I can go to the next slide. As we can see on this analysis per surface chart, most of the Europe is under influence of high pressure fields stretching from, I would say, north to northwest to the Mediterranean and the southeast. There are frontal systems and humid air placed in the northern part of the Europe, and we have here a cyclone situated west of Europe that will approach already tomorrow to the Great Britain and western parts of Europe. So already this morning, so you can see here the infrared image and synoptic observation from 6 UTC. I have noticed that the already quite warm at the situated sea was in some places in Mediterranean, like for example, Barcelona has had 25 degrees, but in parts of the Greece and Cyprus there were 30 degrees measured already in 6 UTC. So local time, it was 7 o'clock in Greece. Also, we can notice that in parts of the Europe there are places that are covered with low cloudiness. And again, I would like you, if you can please annotate it where you can see location with lots of low cloudiness in that part of the Europe, in where you can see this. Yeah, great, thank you. So lots of low clouds, and I think that they are still persisting in places in the middle of the day because this is a 6 UTC. Thank you very much. So you already have annotated locations with PV anomalies, but we can check this by overlaying NWP fields over satellite image, which is really great. And as you can see, there is a PV anomaly placed over here, but also a significant signal over eastern part of the Europe. So this PV anomaly is connected to a cyclone that is approaching UK, and it will bring showers, and it will end the heat wave that is present there already tomorrow. But also in the weekend, it will bring more unstable situation over the most parts of the Western Europe. So I wanted to make a cross section through this system to take a look at this upper level low. So we can see also here is so to say a ridge over most part of the Europe, but some short wave troughs, and this pronounced trough over Black Sea here that brought lots of thunderstorms already yesterday, but and today during this day. So if we take a cross section, and this cross section I took from this point to this point, we can choose, of course, the different NWP fields. I chose, for example, potential vorticity, and here the signal is really nicely seen in this horizontal cross section over, and this is quite common for upper level low. Also, we can have a look on temperature advection, and there is a distinct cold advection ahead of upper level low and warm advection behind it. And as we expect, there is because of this nice anomaly, there is a jet that surrounds this low, and the maximums of are placed around 250 hectopascals. Even we have speeds greater than 50 meters per second present over here. And this is also nicely seen on the infrared image, where I have overlaid isotachs, so we can see that here is a jet stream present, and here in the eastern part, and we have a significant jet in the northern part of the Europe. So if we take a look also on enhanced water vapor image, I would like you, if you can, again annotate the parts of the Europe that are really very, very dry. Yes. Okay. Thank you. Yes. really very dry air over here. Great. Thank you very much for this. And what I wanted to discuss with you about this upper level low, yeah, that on the if we look at this water content, we might be at first not so impressed by it because okay, we see that there is more humid this part than of course these parts over here or over southeastern Europe, but and this perspective we would say it's not so impressive, and maybe it will not bring so much water in western parts of Europe when approaching tomorrow or during the weekend. But I wanted to show you this product. This is total precipitable water showing atmospheric rivers, and we can nicely see that here is atmospheric river that is bringing quite an impressive content of water in this part of Europe. Later on, when I will show you the animation how it looks like, because I must switch to web browser to show it today. So also one more thing that deserves our attention today is this eastern part of the Europe, where I already mentioned that that were some organized convection ongoing already from yesterday morning and today. We can see that there is a significant amount of the Cape, and also before I showed you that there is a jet stream present, so we can expect also some shear here, and so already today is ongoing some convection, and in the afternoon and evening hours some more instabilities can be expected here over the Black Sea. And I wanted to share with you this new, I would say new feature on ePort, and this is upper air profile. So you can pick up a location to see upper air profile for this location. You can see a significant amount of convective available potential energy, and also other interesting stuff that are that we consider while forecasting convection. So this is more or less what I wanted to discuss concerning today's weather, and then there is another, so to say, interesting feature that impressed me in recent days, and for that I must share my other screen. So if you have, you must be a little bit patient, because maybe this will not work so easily. So sorry for this. And this is I found this on Twitter. So on July 5th July, there was a mud volcano that exploded in the Caspian Sea, and it is very nicely visible also on satellite imagery. So just start. Okay, here it is. And I don't know if you're familiar with the mud volcanoes, what they are. I needed to investigate a little bit about it, but it is quite impressive that this is so nicely visible also in satellite imagery. So hope that this is interesting also to you. So, and this is all from me, and now Marko will continue with the weather briefing. Thank you very much.
Okay, thank you, Tanja, for your part. So let's continue on. Sorry. So, okay, I will start with the heat waves in Croatia. Basically, there were 3 heat waves in Croatia this summer and at the end of June and beginning of July. And why I wanted to show this, because all 3 heat waves had rather similar patterns and synoptic patterns, which you can see here actually. Let me just grab something to draw. Basically, all of them were produced by southwesterly flows. So this is the situation and the air mass image on the 24th of June. This is the 29th of June. And this is the 8th of July. So as I said, they were all 3 of them were produced by southwesterly flow, and some of the temperatures, you can see them here. This is a table of maximum temperatures measured in those days in Croatia, and you can actually see really nicely the first wave, the second wave, and the third wave. Here also we have a hot day, let's say, but it was not a wave. The waves are basically they have to be more than 3 days long of very hot days to be a heat wave. And all of those heat waves actually broke some records and equalized some June temperature, maximum temperature records. So you can see here on this map, all of the records broken or equalized were inside of Croatia, in the continental Croatia. So even though the southwesterly flow was going all across the country, most of the temperature, the air mostly reacted, let's say like that, inside in the continental part of the country, because probably the sea kept the temperatures near the coast cooler. Although the temperatures at the coast during the morning hours were very, very high. Tropical, even in some places like Split, Komiža, Ploče, where some temperatures at several days were around 28 to 29 degrees, which is quite uncomfortable to sleep in, basically. Okay, so that's a very short overview of the heat waves in Croatia. Now heat and fires in North America. Let's see what happened there at the end of June as well. You remember those extreme heats that were all over the news in Canada and in the US. Basically, what caused them is this big ridge over the northwestern part of the North America, and this ridge actually formed here over the Pacific. Not sure actually where, it is not probably here exactly, but it formed over the Pacific, and it came over the continental part at around 25th of June, and it stayed there since then until the 1st of July, or maybe even later. I'm not sure at the moment. Anyway, the situation was very stable. The June sun was very long in the sky during the day, especially in these latitudes, and the air was getting hotter and hotter, and especially in the little valleys here in the mountainous regions of British Columbia. And because of that, we remember, or you remember, and you might have heard that the Canadian June record, maximum temperature record, and actually a year-round record was broken in a little place named Lytton. I'm not exactly sure now where it is, but somewhere here it measured 49.6 degrees centigrade on the 29th of June, and so let's go forward a bit, and we'll discuss some other features and phenomena that happened. So I have actually now a short question for you. Please take your highlighters, pointers, or whatever you want, and please select which channels are very important for fire detection. Maybe another one? Okay. Thank you for the answers. Yes, the answers were correct, although incomplete. The most important channel, as you marked at the beginning, is probably 3.9, because this channel already registers the weakest fires and the weakest intensities of fires, and the rest, the 2.25 and the 1.6, the channel which you maybe missed, they register hotter and hotter fires. So 3.9 registers fires at least by Wien's law up to 700 or 800 kelvins, 2.25 up to 1,400, and 1.6 up to 1,800. Of course, there are some technical limitations, so they cannot actually measure those temperatures, but they are quite efficient in detecting those fires. So if we now shift to the next slide, we can see here the cloud phase RGB, which actually uses the two of the channels we have seen, so the 1.6 and 2.25, and it actually detects fires really nicely. It is named cloud phase because mostly it serves for analyzing cloud microphysics, of course, but as you can see, it really nicely sees fires here, 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 for example, and maybe some others that are currently possibly covered by maybe this cloud or something else. But also we can see as well the smoke, for example, from this fire that I just noticed, and then this hotspot where the fire is actually located. And actually, quite funny thing about this and interesting altogether is that those days we had those temperatures, they had those temperatures of around 49 and really high 40s in these parts of Canada in the valleys. And if you look just to the left of the valleys and to the right of the valleys, there is still snow on the mountain tops, which is seen as this blue color in this RGB. Then the next day, on the 1st July, when the ridge moved a bit to the west, some gradients in the high levels of the troposphere appeared, and as you can see, the clouds are following really nicely this circulation, actually this flow of air around the ridge, and basically in these very hot, very dry conditions, when also some gradients appeared in the lower levels, actually basically at the surface, the pressure gradients, some wind developed, and in these conditions, so windy, hot and dry, of course you can expect there is actually a high probability of some fires. And the fires are actually here, and these here are pyrocumulonimbus clouds. clouds that have developed from smoke and the heat which was generated by the fires below. We can see these fires even better, as I already said, in the cloud face RGB. You can see them very nicely in this yellow-green color here and here. And yes, I've noted the town Lytton, where this all-time temperature record was measured. And unfortunately, this date on the 1st July, or not sure, a day or two after this temperature of 49.6 degrees centigrade was measured, the town burned almost completely, or the majority of this town burned, because the fire spread from the forests around it, and they entered the city and well, devastated it quite severely. You can also see again in this image several smaller fires all around Canada. At the end of this heat and fires in Canada and the North America, we will use the fire temperature RGB, basically the best product for fire detection, and actually, as its name said, it is intended for fire temperature detection and analysis. It uses all three channels that detect fires, so 3.7 in red, green 2.25, and blue 1.6, and it detects fires as follows. So the red fires, the red dots, there is no red dot here. So let's say this is a red dot. This fire is the weakest fire, the lowest intensity of fires. Most of the fires, actually, we see these yellowish fires are moderate intensity fires, and probably if we would zoom close enough, we would maybe see here white, several white pixels, which means all three channels are combined, and this is the most intense fire that is viewable and observable with this fire temperature. And we can actually see here the extent of these two fires that produced these two pyrocumulonimbus clouds. And here's one image of said cloud, photographed probably somewhere from the south of it, and was taken from Twitter of this gentleman. Okay, so now just shortly about the floods in Europe, basically what caused them and how the event started. Actually, basically this system, this trough, this cyclone entered through the Atlantic over to central to continental part of Europe, and instead of maybe dispersing, filling up and disappearing, it persisted for a couple of days there. So basically from 13th, 14th, 15th, and even further on, but it moved a little bit then. So basically this system, this cyclone here stayed for these 2 or 3 days and brought a lot of precipitation into the central parts of Europe through showers from cumulonimbus clouds, from common rain, etc. We can also see in this southwestern flow of the cyclone how the dust was brought also from Sahara, and because of that, in Italy and Croatia, I know for sure there was some dirty rain, and people were putting some images of their cars and actually dirty skies as well on the internet. So that was actually a rather interesting phenomenon, and that is actually the same day as Tanja said at the beginning of the briefing. So on the 14th of July, this was probably the worst day for this western part of Germany and Belgium, and then later Netherlands. The cyclone is still there. It is still very potent. It produces a lot of precipitating clouds with a lot of showers and rain, and probably some hail, but the hail was not very important in this situation. And actually, if we check the total precipitable water, actually the total column water from ECMWF, you can see that exactly at that spot in western part of Germany, Netherlands, Belgium, there was the highest amount of available water. So for the cloud basically to grab and drop down onto the ground. And also you can see that everywhere around this northern part of Europe, the total column water was very high, and basically the cyclone could just ingest it in its, could ingest it with its rotation and just deliver it to the clouds, and basically this water destabilized the atmosphere even further. So we can see a couple of days later, after the of the previous slide, the 16th of July, the cyclone, the system is moving slowly towards southwest, and now the precipitation has come basically to Italy, to the Balkans, where Croatia as well received a lot of precipitation in specific places, not all over the country, and there were also several floods and some hail as well. And if we check out now the total precipitation, the total precipitation amounts, we can see that this western part of Germany in 72 hours and 3 days got over, some parts got over 150 millimeters. In Austria, so basically on the way as the cyclone went to southwest, it dropped in 48 hours 170, 163 millimeters all over this northern central part of Austria. And here in Croatia, the data is not very visible, I'm sorry, but basically this is a 4-day precipitation for many stations all around the country, and some of them reached 180 millimeters, 160 millimeters, many of them actually 160, and over 100 was measured in many of them. So yeah, with all this precipitation, unfortunately, there were also a lot of casualties because of the flash floods, as we all heard in the news during those days in Germany and Belgium. And that would be it from me as well. Thank you for your attention, and we can now take some questions.